In this video, I'll explain how to find the rule of a quadratic function when given the zeros and a point. Before starting, remember that a second-degree polynomial function, or quadratic function, can take three forms. Standard form, which uses the vertex coordinates h and k, general form, and factored form, which uses the x-coordinates of the two zeros. In this video, we'll use factored form since we have the zeros of the function. Sometimes a function doesn't cross the x-axis, so there are no zeros. In that case, the rule cannot be written in factored form. Therefore, one of the two other options must be used. Here are the steps to follow when you know the zeros and a point. Start by replacing x1 and x2 in the rule with the value of the zeros. Then replace x and y with the coordinates of another point. To finish, isolate parameter a. Here's our first example. We want to find the rule of a quadratic function with zeros -4 and 2, and that passes through the point 110. Write the basic rule of the factored form. Then replace x1 and x2 in the rule with the two zeros. The order in which they are placed doesn't matter. Let's say x1 equals -4 and x2 equals 2. Be careful. In factored form, normally there is a negative sign inside each of the brackets. When a zero has a negative value, like in this case, we end up with minus a negative number, and so we apply the sign law to get a positive. Minus -4 becomes positive 4. The next step is to plug the coordinates of a point into the rule. The point we have is 110. Replace x with 1 and f of x with 10. Be careful, there are two x's in the rule. Now we need to solve the equation to find the a value. In the first brackets, 1 plus 4 is 5, and in the second, 1 minus 2 equals -1. Multiplying gives us -5a. To isolate a, divide by -5 on both sides of the equation. We get a equals -2. The only thing left to do is to replace a with -2. The rule of the quadratic function is f of x equals -2 times x plus 4 times x minus 2. Here's another example. We want to find the rule of this function. Analyzing the information provided, you'll notice that we have the coordinates of both zeros and of a third point. Just like in the first example, we'll work with the factored form. Start by replacing x1 and x2 in the rule with 7/3 and 51/7. We still need to find the value of parameter a using the third point. Replace x with 9 in both places and f of x with 16/7. Simplify the right side of the equation. Since there are two places where we need to subtract fractions, we must put them both over a common denominator. Inside the first set of brackets, 9 becomes 27/3, and in the second set of brackets, 9 becomes 63/7. When we subtract them, we get 20/3 and 12/7. We then multiply these two fractions and get 240/21 times a. To isolate a, divide by 240/21 on both sides. This is the same as multiplying 16/7 by 21/240. By simplifying the fraction to its lowest terms, we'll get a is equal to 1/5. Now just replace the value of a in the rule. So the rule of the function is f of x equals 1/5 times x minus 7/3 times x minus 51/7. This is consistent with the graph. The parabola opens upwards, and the a value we found is positive. That's it. Hopefully this video has helped you to find the rule of a quadratic polynomial function from its zeros and a point. Watch the next video to find out what to do when you have the vertex and one point. See you soon.